Okay, we're introducing trigonometric equations. So the idea of a trig equation is obviously an equation, something equal to something, and you want to solve for an unknown like x or y or theta. But it involves sine x, cos x, and tan x if you're in the SL course, and throw in cotan, cot, cosec, sec if you're in the HL course. Now, generally speaking, the equations we've come across so far, like a quadratic equation, for instance, has two solutions. A linear equation has one solution. You can have a cubic equation that has three solutions, or a log equation that might have one or two, depending. The thing about a trigonometric function is that they're periodic. They're like waves, or the pattern is repeated. So if you have a particular type of trig equation, you can actually have an infinitely many solutions. So, for instance, sine x is equal to a half. Well, sine x is equal to a half for 30 degrees, or pi on 6, 5 pi on 6, but then it's going to be 13 pi on 6, and it keeps going. Every rotation you take, it's going to be a solution again. So there's infinitely many. So to avoid that, we need to do this type of thing, where we restrict it. And questions will always have this, unless it asks for a general solution, which again is more of a high-level thing. So we look for this kind of restrictions from 0 to 2 pi. So if this is the case, then when is x, what value of x would we have? Sine x equal to a half, or x is equal to pi on 6, that's the first quadrant, and 5 pi on 6. That's the first rotation and nothing else. So that's the solution. We don't have to worry about whether we need to go around again. Now, you do need to take note when reading questions what this domain is. It may very well be from negative pi to pi, and as we go through, we'll look at much more of these things. Now, the majority of trig equations, we're going to do it sort of solving algebraically, but of course, two other methods, and you might be asked in a paper too, for instance, using a graphics calculator to use technology or a very accurate graph, I guess, to solve it. So we're going to have a look at those two techniques as a kind of start today. Nothing too strenuous, just using Desmos or GeoGebra, whatever you prefer. See how we go. Okay, let's get stuck into this first example. Here we have just a simple y equals cosine of x. You notice that it's very nicely printed here. The x-axis, though, is in terms of 1, 2, 3. It's whole numbers or integers, not in terms of pi on 2 or anything like that. So we want to solve, use the graph of y equals cosine x to find, correct to one decimal place, okay, so it's not that accurate, one decimal place, the solution of cos x equals 0.4. So as I go along between 0 and 10, so between here and here it is, you've got to draw a line there for this question. I'll do the next question in red. 0 to 10, when is cosine of x equal to 0.4? Now to do that, we actually want to draw a line, and I might just do it a bit thinner. So to say that 0.4, well, that's 0.5, right? I think two little squares is equal to 0.1. So 1, 2, 3, 4, it's here. So I need to trace across. So this is one point here. Need to trace across. Hits it another. I'm still within my domain of 0 to 10. Trace across. I'm still here. Now you notice that the next time I hit it is outside of 10, so I don't need to worry. So I've got 3 points. I've got this point. I've got this point. And I've got this point. And it's a matter of estimating what the value is for x. Alright, so I find 0.4, I trace that across. Where do I hit the curve? And then I find the x value. Now, that I think is 1, 2, 3, 4, 5, 6, 7. So each little square is 0.1. So I'm going to estimate that x is equal to 1.1. That's my first solution. You can see that, if you had to draw this yourself, it's just pointless. So if you have to use technology to draw the graph, why not use technology to solve it, right? Because if you drew it yourself, there's no way you'd be accurate to one decimal place. But anyway, just as a quick exercise to appreciate the difficulty of this, Then I estimate it to be about 5.1 off the graph. That's the next time, just above 5. And then here I've got 7, 1, 2, 3, 4. Well, much of a muchness. I think it's closer to 7.4, so let's go 7.4. And that's the three values between 0 and 10 when cosine of x is equal to 0.4. Now you can appreciate that if I had no restrictions, if I didn't have this 0 to 10 business, I would have to keep going on forever and ever and ever. Now, it's not particularly helpful, so nor is it practical, but the good thing we do have that restriction. Okay, I'm going to change color. Let's go to pink or purple, whatever it is. So this one is for cosine x equals negative 0.3, okay, between 4 and 12. Now, like I said, it's important you take careful note. If you did the same as 0 to 10, you'll get the wrong answer, right? Because the domain matters. So it's 4 to 12. So we've got, I'm going to put a little line in here, 4 up till 12. And the value we're interested in is negative 0.3. So 1 to negative 0.3. And we trace across here. We hit it once. But that's not, I've done it already, you see? That's outside of my range. I ignore that one. The first one I need to worry about is here, out within between 4 and 12. Keep going. If you use a ruler, of course, it's much easier if you have an actual book. It's here. And then I've got here. Now that's 3. Now, just because both of these answers happen to have 3, doesn't mean it's always going to be 3 answers, right? It could be 2, it could be 4. Depends on the type of function and how big the domain is that you're given. So I take this as being 1, 2, 3, 4. I'm going to take x is equal to 4.4, 8.1. That's this one here. That's about 4.4. And then this one is 10.1, 2, 3, 4, 5, 6. I'm going to go 10.7. Probably it's closer to. Again, not particularly accurate. But that is one way you can do it if you are given a graph. Okay. Now the next one so that's 11a.1, by the way. So 11a.1, we want to just quickly kind of go through the ones that we have. You trace across from the value that you're given to solve that equation. Okay, that's the first one. Okay, now next one we want to use technology to solve the equations. So I'm going to put the answers for A here and the answers for B here. Now, we'll talk about that. So I'm going to flip across to Desmos. And what I do is you kind of you type in the left-hand side and the right-hand side, y equals 6 cos x minus 4, and y equals 0. Taking note again of the factors from minus 5 to 5. Okay, so let's jump across and have a look at Desmos. Here's something I prepared earlier. Let's see whether we go. I mean, I've got y in these kind of steps. I don't really want that, actually. Let's have a default. Okay, so here we go. 6 cos x minus 4 and y equals 0. That's the red line. Between minus 5 and 5. All right. So we're looking for when the red line crosses the blue line between minus 5 and 5. So I'll try to zoom into that. Now, how many times? Well, it does it twice. Seems to be symmetrical. It's this point here and this point. That's 0.841, negative 0.841. That's it. Those are the two solutions within the given domain. So I can write that here. X equals 0.841 and negative 0.841. All right. Now, if we have a look at the next question, it looks a bit more complicated, but the principle is the same. I just graph y equals x tan squared x minus 2 and y equals 5x, and then look for points of intersection. So we go ahead and do that. So if I do that, here's one I conveniently prepared earlier. So we have a look. So x tan squared x minus 2 looks like this. Now if I zoom right out, you can appreciate that doing this by hand is going to be very complicated. So that's why we don't do it. And remember, it's between 0 and 5. And then I do y equals 5x. Now, what are we looking for? Well, x is between 0 and 5. And there's all these points that it does cross, like down here and things like that. But we're not interested in that. We're only interested in between 0 and 5. So I'm interested in this point, it crosses, and I'm interested in this point. And I've got to make sure, actually, there's one more point. I'm going to just pinch it in here. There's one more point where it crosses. You see how it's 4.3. Now, if I look at the next one, it's 5.1. So I ignore that one. So the answers are, now remembering that in the IB course, we want to do into 3 significant figures, which is different from 3 decimal places. So the answers are the x values. X equals 1.20. So x is equal to 1.20, comma, what were the other two? That's that one. X is equal to 1.96 and 4.31. Well, there you go. My pencil decided to die. So I've actually put the solutions below to see how we go. Now this is the ones here. You see how I've highlighted all the different ones? Well, these ones are outside. 5.4, 7.1. The only ones are the negative 8.41, negative 0.841 and the 0.841. And again here, we've got the 3 solutions. So this is 11.8.2. So have a go at that and see how you go. Thanks.